Hi there. Hello there. Are you there? Say hooray. Before that, let us breathe first. Great. Shall we start then? O decision tree algorithm. What is it? What is a decision tree? Do you know? You don't know. A decision tree algorithm is a supervised learning method that is commonly used to model and predict outcomes based on input data. A decision tree makes a statement and makes a decision whether that statement is true or false. Decision tree algorithms can be applied and used in various fields. It can be used as a replacement for statistical procedures to find data, to extract text, to find missing data in a class, to improve search engines, and it also finds various applications in medical fields. For example, you're supposed to live 10 miles away from your workplace. There's no public transportation, the weather is good, and you don't have a car. The decision tree would guide you to consider cycling as the mode of transportation. This decision tree captures various factors involved in choosing a commuting mode, demonstrating how decision trees can be a practical algorithm for decision-making. Terminology alert. Before we proceed in discussing how decision tree works, let us first familiarize some of the terminologies used in decision tree algorithm. So here are some of the terminologies. Root node. It represents the entire population or sample, and this further gets divided into two or more sets. Splitting. It is a process of dividing a node into two or more subnodes. Decision node. When a subnode splits into further subnodes, then it is called the decision node. Leaf or terminal node. Nodes do not split is called leaf or terminal node. Pruning. When we remove subnodes of a decision node, this process is called pruning. You can say the opposite process of splitting. Branch or subtree. A subsection of the entire tree is called branch or subtree. Parent and child node. A node, which is divided into subnodes, is called a parent node. Subnodes are the child of a parent node. That was pretty confusing, right? Let's dig more further. In a real-life scenario, a decision tree algorithm can be applied to automate loan approval decisions at a bank. The algorithm uses factors like credit score and income stability to create a decision tree with branches and leaf nodes, ultimately guiding the loan approval or denial based on a systematic evaluation of applicant information. Let me show you. So here we have a set of data contains income high, medium, or low. Whether that person is a student or not, credit rating poor, fair, or excellent, and default if that person is eligible in taking a loan. Time complexity mode alert. Now let us create a tree out of the given raw data to predict if that person is eligible to take a loan or not. First thing first. Let us identify the Gini impurity of the following data. The following data are income, student, and the credit rating of each individual. In calculating the Gini impurity, we must follow the formula. Gini data is equals to 1 minus the number yeses divided by the number of people of that subtree, minus the number of no's divided by the number of people of that subtree, equals to the Gini impurity of youth subtree. Let us determine the level of income of the following individuals. If their income is low, XX, medium, X, or high. So in the low subtree, we have a condition based on the default column. Based on the table, there are 2 persons who are allowed to take a loan, and there are 3 people who are not allowed to take a loan. So we are going to increment the number of no's and yes in the low subtree. Same process with medium and high subtree. After that, we now have split the following data in terms of their level of income. Let us now proceed in calculating the Gini impurity of those leaf nodes that is impure. Now let us proceed to the next column. Let us determine if the following individuals are students or not. So we have a condition based on the default column. If the condition is true, then let us count how many of those students are allowed to take a loan and how many are not. If the condition is false, then let us count how many of those who are not students are allowed to take a loan and how many are not. After that, we now have split the following data in terms of their identity, whether they are student or not. Let us now proceed in calculating the Gini impurity of those leaf nodes that is impure. So now let us calculate the Gini impurity of student subtree. Same procedure with non-student subtree. Now let us proceed to the next column. Let us determine the credit rating of the following individuals, if their rating is fair or excellent. So in the poor subtree, we have a condition based on the default column. Based on the table, there are 4 people who are allowed to take a loan with a fair level of credit rating. On the other hand, 4 people are not allowed to take a loan with a fair level of credit rating. Same process with excellent subtree. After that, we now have split the following data in terms of their credit rating. Let us now proceed in calculating the Gini impurity of those leaf nodes that is impure. Let us now calculate the Gini impurity of fair subtree as well as the excellent subtree. After calculating the Gini impurity of each leaf node, let us now calculate the total Gini impurity of the data. Let us determine the total Gini impurity of income, student, and credit rating. The formula in calculating the total Gini impurity of the said data is total Gini impurity equals to number of people of the current leaf node divided by the total number of people of all leaf nodes times the Gini impurity of the current node plus the number of people of this leaf node divided by the total number of people of all leaf nodes times the Gini impurity of the current node, and so on. It depends on how many leaf nodes are in that data to plus them all. And now we have the total Gini impurity of the said data after calculating the total Gini impurity of each data. Let us compare the total Gini impurity of each data. Whoever has the least value will be the root node. Now we have determined the root node, which is the student, with the condition if an individual is a student or not. If the condition is true, proceed to the left leaf node, and if the condition is false, then proceed to the right leaf node. After determining who are and who are not students, those who are not students will be asked whether they are allowed to take a loan or not. Since there's 6 non-students, we have identified that there are 4 people who are allowed to take a loan and there are 2 people who are not allowed to take a loan. As you can see, the leaf node is impure, so we need to calculate the Gini impurity of that leaf. Now, among the data, income and credit rating. Let us split the impure nodes by splitting 6 of those people who are not students, by determining if they are allowed to take a loan based on their level of income. If they belong to low, medium, and high level of income. Same with the credit rating. Let us determine if they are allowed to take a loan based on their credit rating. After we split the following data, let us now calculate the Gini impurity of those impure leaf nodes and as well as the total Gini impurity. We already have calculated the total Gini impurity of both leaf nodes. Let us compare who among them has the lowest total Gini impurity, since credit rating have the least value of total Gini impurity. We will use credit rating to split nodes into leaves. In completing this tree, we need to assign output values for each leaf. The output of each leaves depends which category has most of the votes. Since on the left leaf node, most of the votes is yes, so we put an output value, allowed to take a loan. Same with the others who have most of the votes are in no category. Then we label them not allowed to take a loan. Yay! We have finished discussing the decision tree. I hope you have learned a lot. Thank you for watching. Bye-bye.